Welcome to Einsteinium theoretical physics. Let's understand around us. In this video, we will see the journey of physics from the birth of natural philosophy. Astronomy is a subdiscipline of physics, but physics was born when the human civilization started seeing the sky. The roots of astronomy dates to Stone and Bronze Ages, where humans explored the nature and gave us proofs as monuments with alignments towards astronomical significance that were probably used as calendars, times, or to predict nature. Stonehenge in Salisbury Plain, England, a monument made of massive stones, believed to be constructed around 3100 BC. It is not clear who built it. It was aligned in the direction of the sunrise of the summer solstice and sunset of the winter solstice. Large station stones are aligned in the direction of the northernmost moonset and the southernmost moon rise, probably used as calendar. The Majorville Cairn and Medicine Wheel, also named as Iniskim Umapi in Alberta, Canada, another stone monument believed to be dated around 3200 BC. It is an open-air sun temple with a precise 5,000-year-old calendar. Experts say that this marks the changing seasons and the phases of the moon with greater accuracy than our current calendar. El Caracol, the largest Mayan archaeological site in Belize, Central America, dates back to 1200 BC. Another stone monument. The Observatory of Chichen Itza, one of the world's oldest observatories, takes astronomy back to basics. Ancient astronomers could have viewed the stars in 360 degrees, tracking solstices, equinoxes, and eclipses. The Mayans were able to track the movements of Venus and thus measure longer intervals of the Earth's orbit.
Let us see the journey of physics, which routes to the four major civilizations: the Mesopotamia, the Egyptian, the Indus Valley, and the Chinese. Their contributions to the mathematics, astronomy, and medicine influenced later Greek's natural philosophy of classical age between 8th century BC and 5th century AD, centered on the Mediterranean Sea. The interlocking civilizations of ancient Greece and ancient Rome, wherein formal attempts were made to provide explanations of events in the physical world based on natural causes, leads to the birth of natural philosophy, or the philosophy of nature, the philosophical study of physics. It was the time where the celestial objects, such as the star, the sun, the moon, was identified as gods and spirits. The natural phenomena such as rain, drought, thunder, seasons, and tides were related as activities of gods and spirits. The world and the history of astronomy begins in Mesopotamia, with the Sumerians who developed the earliest writing system known as cuneiform around 3,500 to 3,200 BC.
The first evidence of astronomical phenomena found as clay tablets from Old Babylonian period around 1830 to 1531 BC to measure the length of daylight over a solar year.
It was the Sumerians began to divide the circle into 360 degrees in 3,500 BC and spotted that the number of days in a year is close to 360. With that concept, they created a sphere named celestial planisphere with a map of the night sky representing the constellations. Sumerians were the first to use calendars in Mesopotamia during the Bronze Age. The Babylonian calendar was a lunisolar calendar based on the lunar phases.
The 4 moon cycles: full moon, when the moon lit up by sun; waning halves, where the moon shrinks from full to new moon; when the moon shadow faces the earth; and waxing halves, where the moon gets bigger. The number 7 was sacred to the Babylonian. They associated that with the 7 heavenly bodies: the sun, moon, Mars, Mercury, Jupiter, Venus, and Saturn. The 7 days of the week were related to the planets that the Babylonians were able to see in the night sky as the earth completed its annual rotation around the sun. Based on that, later, Romans decided to name the days of the week after the gods and goddesses associated with them as Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. Egyptians demonstrated the high degree of technical skill in watching the sky by building their sacred pyramids to the astronomical alignments the three pyramids of Giza, are precisely positioned to match the three stars in the belt of Orion in the Milky Way. Without the existence of compass during that era, the Great Pyramid is remarkably aligned to the true north, which is the geographic north pole of the Earth. There is a very slight discrepancy of 3/60ths of a degree error, but considering this majestic monument size, this measure has very high accuracy. If we multiply the height of the Great Pyramid, which is 481 feet, by 43,200, we get the polar radius of the Earth. If we multiply the base perimeter of 3,024 feet by 43,200, we get the Earth's equatorial circumference. This 43,200 has got a lot of historical references, like Sumerians' king ruled for 43,200 years. During equinox, we see 43,200 seconds of daylight, and it also represents the axial precession of the Earth. The sides of the pyramids are perfectly aligned to the equator. The Sphinx corresponded to the Leo constellation, while the Nile was considered to be a representation of the Milky Way. The speed of light was standardized in 1983 to be 299,792,458 meters per second. The apex of the Great Pyramid of Giza is located at this very latitude north of the equator, to an accuracy of about 6 significant digits, which is same as speed of light expressed in degrees as 29.9792458 degrees. Egyptians invented the mankind's first official measurement of time as a 24-hour day, the calendar. The sundial with 12 sections, which are about 15 degrees apart, likely served to give more precise times. The clepsydrus, an alabaster water clock with 12 carved columns of 11 false holes, corresponds to the hours of the night. And the merkit, a surveying device for gauging astronomical alignments with impressive accuracy to measure the stellar azimuths. The astronomy of Indus Valley Civilization referred from Harappa civilization around 2000 BC. Their astronomy was known as Khagola Shastra, the science of cosmos. There were prominent astronomers like Laggada, Aryabhata, Brahmagupta, Varahamihira, and Bhaskara. Laggada was the author of Vedanga Jyotisa, the earliest astronomical text. It also details astronomical calculations along with significant aspects of the time and seasons, including lunar months, solar months, and their adjustment by a lunar leap month. Aryabhata was the first mathematician astronomer of Indian mathematics and Indian astronomy. He explicitly mentioned that the Earth rotates about its axis daily, and that the apparent movement of the stars westward is a relative motion caused due to its rotation. He stated that the Earth was spherical, with a circumference of around 39,968 kilometers. He calculated the rotation of the Earth referencing the fixed stars as 23 hours, 56 minutes and 4.1 seconds, and length of a year as 365.25636 days. From the manuscripts of other astronomers like Brahmagupta, Varahamihira, Bhaskara, who contributed to astronomical sciences and mathematics, found that their chapters contain topics about mean longitudes of the planets, true longitudes of the planets, the three problems of diurnal rotation, lunar eclipses, solar eclipses, risings and settings, the moon's crescent, the moon's shadow, conjunctions of the planets with each other, and conjunctions of the planets with the fixed stars. They also contain topics on algebra, arithmetic rules, linear and quadratic equations. Brahmagupta reimagined the identity of zero, seeing it as a number on its own, rather than a simple symbol or placeholder. The first Chinese records of astronomy shows they used the circumpolar stars as their reference point for the heavens. That is, the stars always appear to circle around the north and south celestial poles as the Earth rotates on its axis, and the Polaris appears to stay stationary on our sky. Chinese astronomers tried to precise the time by finding the first day of every month and predict lunar eclipses. The first human record of an eclipse was made in 2136 BC. They used the orientation of the Big Dipper constellation relative to the pole star in early evening and the Chinese clock, a mechanical and horological engineering from Song Dynasty. One of the famous observations was the supernova, the guest star, which we see today as the Crab Nebula. Chinese was the first to invent compass. Before compass was invented, people navigated by looking at stars, landmarks, migrating birds, and waves. Han Dynasty around 200 BC used a mineral named lodestone, which attracts ions, to craft the first compass. They called it south-pointing fish. They used it for traditional artistic rituals such as feng shui, fortune-telling, and geomancy. Chinese Tang Dynasty was the first to invent gunpowder to scare or surprise their enemies. It was used in fire arrows. Later, the counterforce effect produced by ignited gunpowder was used to invent rockets. Following the four major civilizations comes the interlocking civilizations of ancient Greeks and ancient Romans, where physics got its designated name of the history from cosmology. The period of physics, where the natural science or natural philosophy described based on the surrounding nature and fundamental understanding of matter, change, causality, time, and space consistent with logic and experience is called the Aristotelian physics. Followed by period of Copernicus and Galileo, then comes the Newtonian physics. Classical physics took form when Newton developed his theory of gravity and the mathematics called calculus. Following that came the modern physics, a branch of physics that includes the post-Newtonian concepts in the world of physics. It is based on the two major breakthroughs of the 20th century, relativity and quantum theory. Quantum physics came along with modern physics during the journey. Quantum physics is the theoretical basis of modern physics that explains the nature and behavior of matter and energy on the atomic and subatomic level. It is also referred as quantum mechanics. Let our gravity attract you. Stay with us. Thank you.